In this video, we will continue the discussion of fractions on the ACT. In particular, we are going to discuss equivalent fractions as well as the least common denominator for fractions. So, equivalent fractions are two fractions that, while they may look different on the surface, they actually reduce down to equal the same value. So let's take a look at 1/2 as an example. So I think everyone would agree that 1/2 and 2/4, or 1/2 and 4/8, these are all equivalent to each other. And we know this because if we watched the last video on reducing fractions, we'd find that they all reduce to the same value of 1/2, or 0.5. What we can also realize here is that to get from 1/2 to 2/4, or from 2/4 to 4/8, or from 1/2 to 4/8, we simply multiply 1/2 by a fraction that is equivalent to the number 1. So for example, if we take 1/2 and we multiply it by 2/2, I think everyone would agree that 2/2 is equivalent to 1, then we can multiply across, and we get 2/4. So again, we're just multiplying 1/2 by something that is essentially the number 1, but in fraction form. So that'll give us 2/4. So that's going to give us an equivalent fraction. But this isn't limited to just whole numbers. We can also use variables. So we can do something like 1/2 times, let's say, y over y. Because y over y is equal to 1 for all values anyway, where y does not equal 0, because this would make this undefined. So as long as we specify that y does not equal 0 here, the answer here, y over 2y, is going to be equal to 1/2 as long as y does not equal 0. So anyway, these are just some equivalent fractions. So we can do the same thing. Let's say we take x over y, and we want to find something that is an equivalent fraction to x over y. Well, perhaps we want to, again, use just a whole number. So let's say we want to multiply by 3/3. So 3/3 times x over y is going to be 3x over 3y, and 3x over 3y is going to be equivalent to x over y. And again, we multiply by this over here. And we can see, the 3's would cancel here, which is why those are equivalent statements. But again, we can also use variables. So let's just cancel, we cancel those, and you'd see that x over y equals x over y. So anyway, let's use variables. So let's say we want to take x over y and multiply it by something like x, y, z squared over x, y, z squared. And then we would get x squared y z squared over x y squared z squared. And again, that's going to be equivalent to just x over y, because again, when we cancel this out, we can cancel one of the x's up here with the x down here, the y up here with one of the y's down here, and the z squareds here, and we'll be just simply left with the original, which is x over y. And again, we have to specify that x, y, and z do not equal 0 in that case. However, for all non-zero values of x, y, and z, these would be equivalent fractions. So hopefully that makes equivalent fractions make sense. Now let's talk about least common denominator. And least common denominator is important, especially when you're doing any problems that involve adding or subtracting fractions. And to find the least common denominator, we evaluate 2 or more numbers, and we look at the denominator. So in this case, we have 4/9 and 7/24. And the least common denominator is actually going to be the same as finding the least common multiple of 9 and 24. So if you watch the video on least common multiple, one way to do that is through prime factorization. So we can take 9, and we realize that 3 times 3 is equal to 9. So those are both prime, so that's 9. factored, and then we have 24, which we can do 2 times 12. 12 can be broken down into 2 times 6, and 6 can be broken down into 2 times 3. So 3 appears in the factorization of 9 2 times, but only once in the prime factorization of 24. So because it shows up the maximum number of times twice, we drop down 3 2 times, so 3 times 3. And with 24, we realize that 2 shows up 3 times, so 2 times 2 times 2. Doesn't show up any in 9, so we don't need to worry about finding the maximum there. So that's essentially 2 cubes, so 8 times 9, 8 times 9 is 72. So 72 would be, so the least common denominator, 72 would be the least common denominator of 4/9 and 7/24. And what we'd want to do if we were to add or subtract these together, which I'll cover in a different video of adding and subtracting fractions, what we'd want to do is we'd want to create an equivalent fraction for 4/9 and an equivalent fraction of 7/24 in order to add those two together or subtract them together. Okay, let's look at a number with, or a problem with, least common denominator problem with variables. This works the same way. We want to find the least common denominator between x squared y over tz to the fourth and ab cubed over xyz. So in order to figure out the least common denominator for these two values, we would simply break this down into, t times z times z times z times z, and then for the value on the right, we would do x times y times z. And then we do the same thing. We need to figure out the maximum number of times each of the variables appears and throw that as, pull that down as our least common denominator. So t appears once on the left term, but 0 times on the right term. So the maximum number is 1. So t gets dropped down. Then we notice that z appears 4 times on the left term, but only once on the right term. So the maximum number of times for z is 4. So we can multiply by z times z times z times z, or z to the fourth. And then on the right, we also realize that we have an x one time and a y one time. So our least common denominator here is going to be txyz to the fourth. That's going to be our least common denominator for the two terms listed above.